And before you knew it, we were back again with a little bit of Algebra, Chapter 4, Section 2, Writing Equations in Point-Slope Form. Looks kind of like this right here. So, you are familiar with the formula for slope. Subtract points 2 and 1, that's right. Okay, so we have the change in y over the change in x. So now if I take this formula and I multiply by the denominator, so I no longer have a fraction, I multiply by x2 minus x1 on each side. Now this is going to cancel out the denominator over here. So I end up with this equation. Alright, now I want to flip this around so I have the y's on the left side looking like this. We are almost in point-slope form, but point-slope form, as the name says, only has one point. So we only know the information for one point. We don't know it for a second point, so we're going to make that a variable without the subscript number. So it's just y minus y1, that's the point we know, equals m, the slope, times x variable minus x1, also a coordinate that we know. Okay, so in point-slope form, y minus y1 equals m times x minus x1. We know the point, x, y, and we know the slope. That's when we would use this. Alright, so if we're given a point and a slope, it's really easy to write point-slope form. Remember, this is the one that we replace, the one with the subscript 1s. Alright, so 2 is the x here, 5 is the y, and 4 is the slope. So that's where we're going to plug and play. So y minus 5 equals 4 times x minus 2. There you go. It's that easy. Now it's pretty easy also going from point-slope form, like this example here, to slope-intercept form. Remember, slope-intercept is y equals mx plus b. So over here we want to just have the y. On the other side we want to have something x plus a number. Alright, so the first thing I'm going to do is distributive property. Alright, 2 times x gives me 2x, and 2 times 4 gives me 8. So then I have this form. We're almost in slope-intercept form. All I have to do is bring this 3 over here, and that means I got to add 3 to each side. I can't add it to the 2x because those are unlike terms, so I add it to the 8, and that gives me y equals 2x plus 11. Ta-da! Slope-intercept form. Alright, so that is y equals 2x minus 11. Now, this also says write it in standard form. So, for standard form, remember I have to bring the x on the same side as the y. So I'm going to subtract 2x from each side. Since I can't combine these two, I'll write them next to each other, starting with the x term. There we go. Standard form. Now, ideally, whenever you write an equation, your leading term should be positive. So that's what we're going to do. We're going to make this leading term positive, and we can do that by just multiplying the entire equation by -1. That means just change all the signs. So multiply everything by -1. That means change all the signs. Now we have 2x minus y equals -11. And there we go. Standard form. Beautiful. Alright, using 2 points to write an equation. Now, write an equation in slope-intercept form of the line shown. Notice we're talking about point-slope form, so probably they want you to use point-slope form. However, I'll show you an easy trick here. If you have a beautiful graph like this that lets you very easily read the slope, okay, see it goes through this point right here, so I'm going down 2, that's minus 2, over 1. So the slope here is -2, or down 2 over 1. Right? If I follow that same pattern, notice I keep getting a coordinate like this. So I can go the same way in the other direction, okay, going 1 to the left up 2, 1 to the left up 2. Oh, right there it would intersect the y-axis. So this is 3, 1 step further up would be a 4. So now I have my y-intercept and I have my slope. Y equals -2x plus 4. Beautiful, that was easy when you have a graph like this and you can read it. Now, I'll show you how to do it using the coordinates too. But why not? If you can read the graph and it looks this nice, why not read the graph, right? So we'll use two coordinates, and I'll show you that in this example right here. Okay. We want to write a linear function of f for the values f of 4 equals -2 and f of 8 equals 4. Remember, f of something is just a nickname for y. Y equals -2, so that's y. And f of x, all right, is what we have, so that's x. So we have 4 and -2. And then here we have 8 and 4. So they're from function form to coordinates. And now let's find slope. From -2 to 4 we have to add 6. From 4 to 8 we have to add 4. So we have 6 over 4, which simplifies down to 3 over 2 for our slope. That is m. Now, if we want to use point slope form, we'll do y minus y1 is equal to m times x minus x1. Alright, now m is 3 over 2, and the point is whichever point we pick. I'm going to pick the one with the two positives, because when you pick the one with the negatives, more mistakes happen. So if there are positives, pick the positives. So 3 over 2 is the m. Y and x don't get replaced, and then y1 and x1. Okay, pay attention. Y1, and it doesn't really matter which one you pick, so I'm going with these. It's going to be 4, and my x is going to be 8. Okay, now we need to do distributive property. 3 over 2 times x gives me 3 over 2x. 8 and 2 can be simplified to 4. 4 times 3 is 12, so minus 12. And equals y minus 4. Now I need to get rid of the 4, so I'm going to add 4 to each side, plus 4 right there. Y is equal to 3 over 2 x minus 8. And there you have it, ladies and gentlemen. This is a linear function in slope-intercept form, and there it is in point-slope form. Alright, modeling with mathematics. The student council is ordering customized foam hands to promote school spirit. Go school! The table shows the cost of ordering different numbers of foam hands. Can the situation be modeled? Can it be modeled? There's one question right here. Can it be modeled by a linear equation? Explain. Okay, that's our first question. If possible, write a linear model. Okay, second question. That represents cost as a function of the number of foam hands. Alright, which means we have x and y. Okay, cost as a function of foam hands. Y as a function of f of x. Right? So let's check it first. This is up 2, up 2, up 2, and up 2. Alright, we've got constant change up there. From 34 to 46 is up 12. This is up 12. From 58 to 70 is up 12. And this is up 12. So, to answer this first, yes. Yes, it can be modeled by a linear equation because it has a constant rate of change. A constant rate of change. Boom. And that rate of change is 2 over 12, which simplifies, wait, stop, slow down, hold your horses, this is y, so it's 12 change in y over change in x. Be careful. Notice that almost happened to me, and it happens all the time. So the slope is 6. Alright, m is change in y over change in x, 12 over 2, so that's 6. Constant rate of change, which is 6. Rate of change and slope describe the same thing. And then we have all these ordered pairs, beautiful ordered pairs. We can pick whichever one we like. So they're all evens, they're all positive, so we will pick that one. Alright, point and slope, point slope form, y minus, this is the y, right here, 34, is equal to slope 6 times x minus, and this is my x value 4. So distributive property 6x minus 24 y minus 34. Tricky, looks like a 9 there. We add 34 to each side. Boom, plus the 34. And that gives us y is equal to 6x plus 10. And there you have it. We have written a linear equation, simplified form. Shoop! Ladies and gentlemen, that is Chapter 4, Section 2, Writing Equations in Point Slope Form. Y minus y1 equals m times x minus x1. Remember to like and subscribe and smash that notification bell if that's something you're into. See you in the next lesson.